We are climbing the ladder to the stars. This will be a little poetic, right? And we're not just gaining knowledge. Remember how I said before, we're gaining a way of thinking, a way that empowers people to question. So what have we done? We got 5 clues from looking up. Then we wondered about some puzzles, as an example. 3 dudes of ancient astronomy had some ideas. Not a ton of evidence, but they watched. I mean, it certainly was good. They gathered what they could, but no telescopes, right? Before Common Era, certainty, push our certainty scale and coming to know through processes and questioning and testing and being willing to be wrong and get more and more certain as the tests get more and more correct. And then we wondered about, does everything go around Earth? What do we call that? Geocentric, versus heliocentric. I'm going to get to that. Ptolemy versus Copernicus. We talked about heliocentric alignment last time, so know your opposition, conjunctions, maximum elongation, maximum angular separation. We touched on the angle thing, good enough. Parallax, remember that was key. And now what I'd like to do, we've only got 1, 2, 3, 4 more to go in our 9 dudes list to get up to a scientific revolution. I want to do Tycho Brahe first, and he connects with Kepler. I'll do that in another one. So these 3 were around the same time, especially Kepler and Galileo, and around 1600 is a good time frame for him. And we're going to see Newton is about 1700, late 1600s, so we're not going to be picky about that. So let's do this idea, really. It's not so much about the person as it is about the idea. So remember, we've got this. We've got, is everything going around us? Oh, it must be. We don't know how far things, maybe the stars, fixed stars, are on some fixed crystalline sphere. Maybe their sphere is 7th heaven, right? That was an idea. The heavens out there, perfect and unchanging. Let's see. Well, all we can do is look and measure, right? You've just got what you've got. People have been doing that for a while, and then you go over here and you go, whoa, wait a minute. Could it be that Earth is a planet that orbits a sun? That scale is ridiculous, of course. But do all the planets orbit the sun? Heliocentric? Well, so there's the ideas, right? Review is always important. Here's where we're going. We've got geocentric, which on our list, again, an incomplete history to be sure, but we've got Aristotle, and then about 500 years later, right? 500 years later, we've got Ptolemy, 150 Common Era, formerly known as AD. We've got the heliocentric, which is that model there where Earth is actually a planet, like those dots. That's a weird idea. It goes way back to Aristarchus, like Aristotle, and Copernicus, way over 1,000 years, if you want to figure out how many, 1350, but later than Ptolemy. So Ptolemy's idea really held sway in the politics and interesting times. You should just chunk that out. Right? No need exact dates. And so here we are at a tie. You see, both of them were a little bit off from our observations, but they're really good. But they were so picky about the timing, and you could question it because people wanted to know. So that was good. So enter, you can say a Tycho or Tycho. I like Tycho because Tycho breaks the tie. He's a company. He's the tie company. He breaks ties. You got a tie? I'll break your tie. Tycho. Or Tycho. Brahe. I put up, you don't have to memorize, of course, these dates, but it's interesting. He died when he was 54, which by today's standards is pretty young. He was quite brilliant. Interesting. I'm going to show you some pictures at the end here. But so we're talking late 1500s. And this idea was out, and this was kind of known. So he knew, okay, we got a tie game here. What am I going to do? I don't know. What are you going to do? Well, I'm going to use logic. mean, how did he get what he needed to break the tie? How did he get what was right? Did he just use logic? Like, well, it seems this should be true, and if this is true, then this should be true. That seems right to me. No. You can't just use logic. Right? Logic is important, but you can't just use logic to figure out the way things are, because if you look at the history of science, we are quite surprised by many things. Logic would never have gotten us there. By arguing, oh, you ninny, whatever, you cackling hen, you hard-headed bull. Did he just argue? No, he didn't just argue. Like, you're wrong, I'm right. Did he use authority? Hey, Aristotle said so, so it must be right. Or some other authority, or his own authority? Hey, I'm the authority. Did he use his personal comfort? Like, oh, it makes me feel good to think that we're at the center and everything goes around us. I like that idea. The heavens are out there, and it makes me feel comfortable. Well, that's fine, and sometimes we do that. That's okay. If you want to know the way it is, it doesn't matter whether you're comfortable or not. Did he use his intuition? Did he say, well, my intuition says, see, I got to do better. My intuition says this or that. You use your intuition, hopefully from experience, and if you have more experience, your intuition might be, to guide you into where to explore, but you still need to explore. Your intuition might be right. It might, just because it seems right doesn't mean it is right. And, live life and notice that that is certainly true. So no, he didn't. What did he do? Well, he read the book. No, there wasn't, the point here is there wasn't a book, right? There was no textbook. So what did he do? What do you do? How do you break the tie? What's the new approach, the new way of thinking that's developing here? This is quick, okay? It's kind of short, but it's important. People have been looking up for thousands of years. And he said, well, I'm going to go look. Why? It's been done. We got thousands of years. We still can't break the tie. What are you going to look at? I'm going to look at sun, moon, planets, the wandering planets, even though you might call sun and moon a planet in the old way, and the fixed stars. But it's been done. What are you going to do? Well, I'm going to do it better. I'm going to do it better. So he knew it wasn't in just thinking about it. He had to go out and measure it. And you'll see this typed out in the book in a little more maybe clarity or complete sentences. So what did he do? He did this. Now he didn't just, he watched these things, but he measured it. And telescopes weren't around quite yet. Right near the end of his life, they'd been developed, invented, but they weren't very good. We see Galileo improved it, didn't invent it. So he would line them up. And he would measure the angular separation, but he did it the best possible. You cannot, a human being, their eyes cannot do better than he did back then, 400 years ago, right? And he'd have devices to measure that angle. I think he probably did better than this, though. I'm guessing he did a little better than that, right? He lined it up. It helps to have good equipment. If you have good equipment, it helps to have money. So he was pretty well connected. Interesting politics there, because that fell through. And someone died, and a new guy. And it's an interesting story. I'll control myself, but it's interesting. So you cannot do better with your naked eye and sticks or something to line up those and measure the angle between those things, right? Your thumb and your fist and your pinky give you a sense, but that's pretty rough. You could do it really carefully. People have been doing it. But he said, let's just look really carefully. at the angular separation between sun, moon, the 5 naked eye planets, you know their names by knowing the days of the week in Spanish or Italian or Latin, and 1,000 stars. I'll come back to this in a second. So that's what he did. Okay. What did he think? What was his intuition? Let's go back here. This is kind of interesting. See, he was trying to break the tie, trying to figure out what was going on. What's going on here between, who is it? Is it the geocentric camp or the heliocentric camp? Which one's true? Notice I put him kind of in the center. Which one of these is really going on? And so his idea, I'll show you a picture here in a second. It was kind of this combination thing. It was kind of like this. It was like, okay, Earth is here. And sun goes around Earth. But the planets go around the sun. It was kind of, so it's a mixture. It was this hybrid kind of thought. But that doesn't matter, right? Because if you want to know what's true, I mean, if he banked on that, then he might try to skew the data, right? Not good. If you really want to know, that's not honest, right? So you can skew it your way. That's not honest. If you really want to know, you got to let go. You got to go, well, I think this is true. Let's check it out. Let's find out. What I really want to do is not be right. What I really want to do is find out. That's a different way of thinking, right? It's driven by a different cause. What is that cause? To know with more certainty. Science. If I want to know more certainly, it's like, okay, interesting. Now let me check it out. Let me test that. You like astrology? It sounds good. Look deeper. Test it. Challenge it, right? But not, again, not simplistic challenges. I call them playground challenges, like just being, really look at it, right? And so astrology is kind of cool, but it fails, really. You can find places where it seems like it's right, but if you look closely, it's not even close. Anyway, it's a new way of thinking. What else did he find? There's one other thing that I want to show you. So that's what he did. We're going to see what happened. I'm going to tell you a little bit about the story here too, with those dots. I'm going to go over here and say that there was something else that happened at that time. A bright, bright spot appeared in the sky, and you could even see it during the day. And this was interesting because if it was out there with the other dots, then that would say that the heavens had changed. But it was taught by authority. Heavens are perfect and unchanging. Now they said, so one answer is, well, they're not in the heavens. It's close to Earth. It's right here. It's a flying bird that is burning for a long time. I don't know. It's something, I don't know, but it's here. It can't be out there. Can't be out there. And with this idea of measurements, good old Brahe said, well, let me check that out. And there's a quote of him saying, when he was interviewed, he said, yeah, well, I did chapter 3, exercise number 9, and I found that with parallax, looking at something like that, or looking at it at different times, and looking at what's behind it at night, what stars are behind it, when things are close and you go like this and this, it shifts quite a bit what thumb is behind. But as it gets farther, it's a smaller and smaller shift. Farther, it's a smaller and smaller shift. So he had to be good at measuring these angles very carefully. And he said, that thing is so far away, I get no shift whatsoever. It's out there. Perfect and unchanging heavens? Not. Okay? We'll see, I'll give you a little taste of the history on this too. So he measured this really, really carefully. And so what I want you to do is imagine this. He's figured out, I guess I should tell you a little bit of the story and then I'll show you the picture. He's figured out, he's night after night, I'll show you pictures in a moment. You could do a web search. He's got these pictures of these dots. There you go. What's the angular separation each night, night after night, or every clear sky, whatever it is. Now, okay, so what is it? Who wins? Is it geocentric? Is it heliocentric? Or some combination? What's going on? Now, Brahe was again, an interesting story and maybe a character of sorts, but he was quite brilliant and quite capable. But he knew he needed some help figuring that out, and he called on Kepler, Johannes Kepler. Now, yeah, maybe I'll tell you. So, well, let me tell you with pictures. Let me do that. Remember this, a stack of dots, and somehow you're supposed to figure out this puzzle of the ages for thousands of years. The sun going around us? And a lot of people didn't even consider, are we going around the sun? Are we moving? All right, let's come over here. Still with me? You're still with me. All right, quick little thing, and we're done. But the idea is profound, right? It's the way of thinking. So I just typed in here on the computer. Tycho Brahe. Tycho, break the tie. Now Wikipedia, you have to challenge that too, and there's lots of information, but I do find that on science, people jump in and make some corrections. Besides, it's got some good pictures. So here he is, clearly a poor man not, right? He was connected. He was connected, and he also had quite a mustache. He'd be kind of rocking it now. That'd be pretty cool. I like that people can do whatever, and it's fun now. Anyway, he had money. He had resources. Politics was in play at the time. Still, good connection, great signature. There he is, the dude, Tycho. Now, there's stories about this, and I had these demonstrated here, but it was a duel with these rapiers, and I guess he was, 18, 19 something, and he got a chunk of his nose cut off. This wasn't from his, but it's an artificial nose back at the time. I don't know, was it common that people got their nose chopped off? That was kind of funny. But luckily he was connected, so he can get himself a replacement for a part of his nose that got chopped off. And I've heard many people say that the story was that the argument was over a girl, and I don't know, I kind of like that story, but it seems that history more validates that he was actually arguing over these things. What's really true here? Geocentric, heliocentric, what's going on with a fellow student? Why would you? Well, I don't know, because you're 18 or 19. Anyway, there's some other character, but there they are, the dots, right? And he would measure the angular separation, and he would figure this out. And man, nice handwriting back in the day. No way. Look at this setup. He was out on an island, and you'd set up different observation points, right? And you just measure, because that's the key, right? The key to science is wonder about something and some things, and then measure it and test it. Measure and test it. Be a bit skeptical, right? I don't know. Let's look deeper. I don't know, Aristotle. I don't know if that's right. I don't know, Copernicus. Is that right? I don't know, Ptolemy. I don't know. Let's measure it. Let's try to figure it out. And so here's a painting of him, but he didn't do it by eye like that. He did some measuring devices, and look at that. Sketches. just like we just did, right? That's why we wanted to do that heliocentric alignment. You get this sense of people are drawing pictures. They never left a planet yet. He didn't even have a telescope yet. Just coming around the corner, right? In fact, shortening the story, look at the politics, but his funding went out. He lost his funding. King died, and this guy, son, whatever, took over and lost his funding. And then he went over and got Kepler to work on this stuff with him. And Kepler was a brilliant mathematician, but Brahe was no slacker himself. He was pretty darn good. And then it's like, what are the dots telling me? What's really true? What's going on? There was a lot of controversy about his death, not being sure why, but I think forensics, etc. I think they've kind of figured that out, but I'll let you dig into that. So his idea was here, moon goes around Earth and planets go around sun, but then sun goes around Earth on this circle. That's what he was thinking, some combination, but it doesn't matter. If you measure it and you find out you're wrong, but you still figure out the way it is, that's all that matters, right? It's a different kind of perspective. And there it is, Tycho Brahe, Johannes Kepler, that combination. Notice the measuring instruments and the maps. So I would guess this is Brahe and Kepler. Yeah, that's right. Anyway, it was amazing because what they did, I don't know what that is. All right, no idea. That's pretty cool. Tip of the iceberg. It is the tip of the iceberg. All right, so that's it. Got it? That's what Kepler did, Brahe did. And we will talk now about what Kepler found by looking closely. Oh, hold on. Don't go yet. So then Brahe died. Now you can check my history, okay? But the story that I get, that I think is correct, is that he died, and then the dots were there. This is intellectual property. There were legal systems, right? The Greeks set up legal systems, and other cultures had their systems, right? So who gets them? And the family apparently wanted them, but Kepler knew what to do with them, and what I hear is that it was held up in the courts so long that by the time it was settled, Kepler had figured this out. I think I've heard both, that the family got him and Kepler got him. You can look into that. People. They were people, right? And they had kind of some modern, what we would say modern systems. We're talking about 400 years ago. So a lot of things were in place. Universities had started, etc. And we're getting into the Renaissance and even the late Renaissance. And we still don't know. And we're just about to develop telescopes right there. And we still don't know, is it heliocentric or geocentric? But we got a bunch of dots done by this person who did not settle on this. Not that he didn't argue. Maybe he lost part of his nose. Sure, he argued. Sure, he did this, dive right into that. I mean, he had an intuition. But you rely on the evidence and you go get better evidence if you're not sure. And that's what tells the story. That is a profound shift in thinking. Certainty, science, right? And that's honest. And so let the truth be with us. Let's check out